All right, welcome to the week 7 project series. We're going to be doing the projects for this one, week 7. Let's get started. Okay, week 7. This is what we're going to be doing on basically week 7. It's similar to your assignments. We're going to be doing the regression line here for the scatter diagram. And we're using ROI and cost as your two variables we're using. Okay, let's get started. The first thing we're going to be doing is getting our data first. And I already have this value in here. This is what I'm having in here for the question for us to look at and what we're testing. And what I'm going to do is, so I can keep everything straight, I'll make sure I'm highlighting the actual data we're using. So annual ROI we're using and cost. So these two factors. What I'm going to go in and do to make it easy is for annual ROI, this is our Y value. So I'm going to go ahead and put that in there. And this helps us and help you and me to keep it straight. And over here is your X value. Over here is the X value. And now we can actually build this. So the first thing we have to do is draw a scatter diagram using that, right? And draw the fit of the regression line and all this stuff, right? And calculate the estimated annual ROI between X equals 160. So in order to get the line equation and all that, we have to create it first, right? And I'll show you how to do that using the data analysis tool package, which is our favorite one, right? So, and then we're going to test this hypothesis. So we'll just do insert, data first, excuse me, data analysis. And we're going to be doing, let's see here, regression, I think. Yeah, let's try the regression, I think. Okay. Now we have the X and Y values we're trying to input here. So Y is right here. And we already verified because I made sure that I put it in there with it, right? Y is annual ROI. And then your X value is right here. And we do have labels. And we didn't have anything about any kind of confidence level or anything. Okay. The next thing we're going to do is we're going to have what we called here a fitted regression line. So I want to line fit test, line fit plots. Okay. And the reason why we're doing that is because you're going to have the R squared value. You're going to have that value, the coefficient of determination R value in there. And we'll get the line equation code and all that in there too. So output range we need. We select here, and I want to actually put it somewhere that's below here. So let's put it right there. And I think we're good. So this is your settings. And I think I forgot to put the chart in there, which is very important. So I can go back and run that again just to make sure. Unless I didn't. Oh, there it is. It actually gave me a chart. So I actually have to make that bigger. Let's go ahead and scroll over here and make that bigger for us. So we're bringing it over here, and we can actually have that in there. I don't like this one. I'm going to see if I can actually do another one to make sure we're on the right track for this. We need to do the line and everything too. So let me see. Data analysis. Push OK. Regression. And okay, well, it's not going to let me do it. Residual plots. Nope. Standardized residuals. Okay. We'll just leave it there. Okay. Push OK right over it. That's fine. And what we're going to do is I'm going to go ahead and make it bigger so we can play with it. One of the things here you can do is you can adjust this right here so it's not so far over to the right and left or top and bottom. So you can right click on this data here and you can go to format axis. And what I want to do is set it to 50 for the major line here. I think it was already there. What's the minimum line? A minimum line there. 50,000. And when I do that, you see it coming over. And And that's good for that. You push OK. Get out of there, right? And over here you can select this one and right click on it and format the axis. I want it to come down a little bit, so I'm just going to put down here maybe 6%. So 0.6. And it brings it down. Not 60, 0.06, sorry. You might do the same thing. There you go. So now it's not as far. Right? Okay. So it's basically, here we're not done yet, so we have to select the values here, which is the blue values, because we want the Y values, right? I want to go ahead and I want to add in a couple things here. Add a trend line, and I want format the trend line. Actually, it's right here. I want to actually have the display of the R-squared value on the chart and a line equation too to help us. And also, I want to go ahead and click on here, and I want to display the line equation on the chart. This line equation is important, and we're going to use that up here so we can kind of see around. Okay, we'll use these values here. I'll show you where that is over here. The R-square value is right there. Okay, you want to highlight that. Excuse me. R-square value. You're going to use these two, the X and the Y intercept. And if you see that over there, 0.11 and -2, you'll see that over here. -2, 0.11, and what's that? 0.07. That 0.07 is, where's it at? It's supposed to be right there. Okay, that's the value right there. That's the first variable, predicted variable. I think that's right, 0.07. So this is your line equation, right? So you're taking this line equation here, and it's not actually 0.07. I'm going to show you. I think I messed up telling you that. Sorry. Come on. I'm trying to make it bigger, but it won't let me. Anyways, this won't, it's actually 0, E0. That's E, right? So it goes over 0 to 0. So what it is you, it's 2.2, whatever, -2, and then times X plus 118, 0.118. So what you do is you'll take that value over here, okay? And what we're trying to get to is the 160 X value here. Okay, I'll copy that. I'm going to put down X is equal to, right here, this X value, 160. And this is the dollars, right? So our X is 160. So what we're doing is we're having, this is the calculation now for the predicted value, because we're trying to figure out what is the calculated estimated annual ROI. Calculate the estimated ROI. So I'm going to put it right here. Estimated annual ROI is going to be, because we're using that line equation, and if I can copy it over here, you'll see it. Won't let me do it. Okay. Just know that is right there. X plus, so it's this equals this plus, let's see again, make sure we're good, equals that times, so we want to go like this, times that. So we want to actually put this in a little bracket here, because we're doing this factor first. And then we're going to what? Add in there the 0.118, which is that value, plus 0.118. So this is our actual predicted or estimated annual ROI value right here. So I'm going to highlight that. So we actually had to calculate this. So once we get all this information, we had to do all this, right? And yes, we got a little bit more than we needed, which was great because now we have the values we're using to predict. It tells you the residuals from the actual predicted value. So like, what are the differences? These are the actual values. Okay, these are differences from the actual value. Excuse me. Here's a predicted value right here. They're trying to predict it, right? The R-square value is 0.94. Okay. So basically now we're at the point now, how do we test this right here? Okay. So the observations are what? So we already found the answer for what is this right here? Okay, I'm gonna go ahead and close this out. It's bugging me now. You had to calculate this value here, which we did. So this answer would have been the 0.084 or equals, like you did this, you can go 8%, right? What is it? 8.42%. That's right there, right? That's that one, because you did it like that. Because 0.08 is that, right? So that's what the annual ROI is estimated based on this information. Now you have to test this right here, hypothesis now. So what does that mean? Let's see. And we're looking at the test. We're testing the actual hypothesis. And okay, 1 second. All right, so basically we're trying to figure out how to test this, right? This hypothesis here, okay? And some of the things we're looking at is the significance level here. We want to look at these values here. I'm showing you here because we're using these factors to do the F statistic, which is basically using these two values here. And I'll put in a little box here for us so we can actually see that, what it is, how it works. So the F statistic is doing this. Okay. And basically that's how we got this value here. You actually take those two values and it runs it automatically for you from that output. And we're supposed to be getting the p-value and all that. So, so what we're looking for, let me show you. This is what we're looking at right here. The F statistic is actually associated to the p-value. Here's your p-value right here. Okay, it's already calculated for you. So what we're looking at is to see if the p-value is greater than the 0.05 significance. And this is actually what we're constructed as by default, 0.05 significance level. And since this value is actually greater than the 0.05, we do not reject this hypothesis here. We actually accept it. And we undo that. And this is basically, we didn't have to do no calculation at all. We're just saying that right here, right? Also, another important note is this is talking about the R-squared value. Okay. And basically the one value here we're actually using is a 0.941, means that 94.1% of the variation around y and y bar, which is the actual slope, and its mean, is explained by the x. So, and that's what that means right there. So based on x value, that's what 94% R-squared value is talking about. That it's the variation around the y area. So for this one here, you're looking really at this p-value here. So if we actually took this value, and it'll be fine if you just went like that. They wanted it there, so let me see if I can take that out of the way. There you go. So this is the between the two here is the same if you look at the numbers there. Basically, what you're doing is seeing if there's any differences between the 0.05, which has to be greater, right? So this value has to be greater to accept it, right? So we do not reject the null hypothesis. Okay. And once you get all this, you already have the value here. And basically you just do that for both sides, engineering, and you do it for the actual, we call it LSI too. So right here, example again, 1.644 is greater, so we don't reject it. And you'll compare that again on the LSI side when you get it over there. Okay. All right, so this concludes week 7.